Alright, welcome to the quiz for solution video. So this quiz was based on projectile motion and forces. So for our first question, it's a true-false question. It says the velocity is 0 at the apex of projectile motion. So first we should think about the definition for velocity. We have Vx I hat plus Vy j hat. So this is the definition for velocity. So we need to consider the x component and the y component as well. So if we look at a general, let's pretend that's a nice smooth parabolic shape, the apex is going to be the highest point. So we are no longer moving up and we are moving downwards. So in the y direction, our value is going to be 0 in the j or y direction. However, we are still going to be moving, in the case of how I've drawn my arrow, to the right. You could also be moving to the left. It's equally valid. However, we would have a Vx value. We have some velocity in the x direction when we're undergoing projectile motion through the entirety of our path. So that is going to be, oops, not true. That is going to be false. The velocity is not 0. We have an x component to our velocity value. So here we want to look at the forces of a baseball flying through the air in real life for number 2. So as we have a baseball going through the air, we know that it is going to be affected by the force due to gravity because it is going to move downward as time goes on until it hits the ground. In real life, we do have air, so we will have air resistance or drag. You could have written it as air resistance or drag. Both would have been fine. In this case, they mean the same thing. We don't have a normal force because it's not on a surface. There's no friction because we're not on the ground. There's no tension because there's a baseball doesn't have a rope attached to it. There's no thrust. Last I checked, rockets and baseballs were highly not doable. So that's going to indicate that these are going to be the only two forces we have acting on our baseball as it is flying through the air. So it's key to look at that it is flying through the air, so it has left the person's hand. So for number 3 here, we have a projectile motion question. You didn't have to draw a picture, but I always think that it helps. So I'm going to have my origin here at the bottom of my box. I'll have positive x to the right. I'll have positive y upwards. And the person is going to be kicking the ball from up here, which happens to be 2 meters up. Obviously not to scale. So because of my origin, my initial position is going to be 0 meters for the x position, and my y position is going to be 2 meters. I don't know my final x position. That's going to be what I'm solving for in part B, so I can just leave that as a question mark. I am going to be landing on the ground. Again, based on my coordinate system, I've defined that as 0. The ground is 0 meters in height, so that will be 0. If I look at my initial velocity in x, I'm told that I'm kicking the ball horizontally. So when I am kicking this ball, it is going purely in the x direction. So it's going to be 13 meters per second in x and 0 in y. My final velocity in x is also going to be 13 meters per second because when we do projectile motion, we are ignoring any air resistance. Oops, that should be Fx. I don't know my final velocity in y. Not going to be important in this particular case. Ax is going to be 0 meters per second squared. Ay is negative 9.8 meters per second squared. And I do not know the change in time. That is going to be what I'm solving for in part A. So this is personally how I'm going to be setting up my question. It is equally valid to say that your origin is at where the soccer ball is starting. If you do that, your final position is going to be negative 2 meters. So just make sure that you are aware of where you are setting your origin and making sure that you are using that throughout the entirety of this particular question. So let's go ahead and solve for part A. So we are solving for the amount of time the ball is in the air. So we're not going to be able to solve using the x direction, so we need to use the y direction. And only one equation do we have all of the information for. If we look for the first kinematic equation, it has time in it, but we don't know the final velocity. The second kinematic equation, we know everything in there except for time. For the third kinematic equation, there's no time in there. So it is perfectly valid to use the third kinematic equation to solve for the final velocity and plug that into the first kinematic equation and solve for time. That's too many equations for me personally, so I'm going to want to use the equation where final position is equal to initial position, which is equal to the initial velocity times time, plus 1/2 acceleration change in time squared. So based on my coordinate system, that is going to, my final velocity value, or my final position is going to be 0. And based on the fact that the soccer ball is being kicked horizontally, I do not have an initial velocity in the y direction. So what I have is that my initial position, I'm going to do minus 1/2 g delta t squared. So I've plugged in that my acceleration is negative g here. I can now rearrange this and solve for the change in time. So the change in time is going to be negative yi divided by negative 1/2 g square root. I can simplify this down because I'm going to be honest, I hate having double negatives in here and I don't like dividing by a fraction. So I have 2yi divided by g, and I need to remember to take the square root for this. So I have all my numbers. My initial height based on the coordinate system I've chosen is 2 meters. The acceleration due to gravity is still 9.8 meters per second squared. So I can take this and plug it into my calculator. Let me redo that because naturally I cleared it. So I'm going to have 4 divided by 9.8 square root, oops. So when I took this and plugged it in, I got 0.63888 seconds, rounding to the correct number of significant digits, which in this case is 2. I'm going to have 0.64 seconds. So in part A here, I've used the y direction in order to go through and solve for the amount of time the ball is in the air after being kicked off of this box. So in this case, I don't need to use the quadratic equation because my initial velocity was equal to 0. If I had a non-zero value for my initial velocity in the y direction, I would need to use the the quadratic equation in this case. So let's look at B. So for part B, we are solving for the final position in x. We only have one equation that we can use. So again, based on my coordinate system that I'm using, my initial position is equal to 0. So that means I'm just going to have the initial velocity in x times the change in time, which I just solved for in part A. So I need to use my 13 meters per second that I have, multiplied by my change in time, again making sure that I'm carrying a couple extra digits when doing my calculation as to prevent a rounding error. So when I plugged it into a calculator, I got 8.3054. 5, 4, and this is going to be in meters. Again, rounding to the correct number of sig figs, which is going to be 2. My ball is going to move 8.3 meters away from the box. So as with most projectile motion questions we've done in this class, we have used the y direction, in this case, to solve for time. Now that we have solved for time, we have found the final position in x in which our ball is going to be located. All right, so that's the quiz solutions. If you have any questions, please let me know.